getting sick and having absolutely no way to prevent it from happening? Not ideal. While the medical community has made huge strides in understanding how pathogens cause disease and developing treatments to fight against infection, detecting airborne viruses and preventing them from entering our bodies remains unreasonably difficult. And by difficult, I mean virtually impossible, because there's not a whole lot to protect us when we breathe. But there's hope, and it comes in the form of our fourth state of matter, plasma. Engineers just demonstrated a proof-of-concept plasma reactor that inactivated or removed 99.9% of a test virus from the air in a fraction of a second. Prized for its powerful disinfecting qualities, plasma has already found plenty of applications in industries to chemically extract particles from the air, but using it to target viruses is a totally novel application. Viruses are the most abundant biological entity on Earth, and some of them, like measles and the common cold, travel by way of sneezing, coughing, and breathing. And boy, do they travel. Sneezes can launch germs up to 8 meters in a matter of minutes, where they can remain alive in the air for hours. And there's even a theory that viruses are able to hop on the backs of dust and soil particles and coast around the world on high-altitude air currents. So the global air purifier market is projected to reach approximately $6.2 billion by 2023. So clearly, this is a thing. And if you have one at home, it's probably either one that's designed to trap particles in a filter or deactivate them through a chemical reaction. And all of them have their downfalls. Electronic air filters, like electrostatic precipitators, can be efficient for extracting particles, but they don't remove gases and smells and can produce harmful byproducts. Mechanical systems, like HEPA filters, can have difficulty capturing and removing all pollutants that enter an indoor space, especially one that's not airtight, and they also tend to have trouble with microorganisms and bacteria bypassing the filter. Another type of air purifier, like ozone generators, are specifically designed to deactivate or destroy pollutants, but they actually just release an inorganic molecule that's a toxic component of smog. So what makes plasma so promising? Let's break it down. First observed by Sir William Crookes in 1879, plasma is the fourth state of matter after liquids, gases, and solids. It's comprised of a cloud of free-flowing ions or electrically charged atoms, but the cloud itself has no overall charge. While plasma exists when molecules are heated to extremely high temperatures, it can also occur at room temperature if the molecules are exposed to a strong enough electrical field. This is known as cold plasma, aka non-thermal plasma, and it's the kind we want to use if we want breathable air. I mean, normal plasma could also make things clean, we just can't breathe air at temperatures that high. Now, just to be clear, plasma is already being explored by industries to take pollutants out of our air and water. But using plasma to rip viruses apart, that's a whole new ball of electrons that engineers at the University of Michigan have just unraveled. Using a cold plasma reactor, they were able to inactivate or remove 99.9% of a test virus from their experimental airstream in a fraction of a second. It works like this. As the virus flows into the reactor pipe, a large voltage is introduced to create an electric discharge, or a spark. A bed of dielectric beads sandwiched between the electrodes maintains the spark of the plasma, whose unstable atoms oxidize the virus as it moves through the pipe. Upon exiting, the virus is then merely a shell of its former self, with an extremely diminished capacity for infecting a host. However, it's not entirely clear how cold plasma works to inactivate viruses. It could be that the presence of the electric field causes their shells to expand and rupture, or that the fragments of the air molecules chemically attack them. But whatever it is, hey, it works. This successful proof of concept holds a whole lot of promise for putting the brakes on airborne viruses. It combines both air purification and inactivation of airborne pathogens, making it a more effective option for disease control than the air filters we currently have. The University of Michigan team has already begun trialing cold plasma's effectiveness at nearby livestock farms, where the risk of animals contracting airborne viruses is extremely high. Because, I mean, if we breathe 3,400 gallons of air per day, it would be nice if it were virus-free. If you want to learn even more about viruses and other infectious diseases, make sure to check out our new series, Sick, and don't forget to subscribe for more Seeker. I'll see you next time, and thanks for watching.